Hello everyone, my name is Vimal Raj. I'm a lecturer from Mechanical Department from GEMS Polytechnic College, Aurangabad, Bihar. So today we were going to discuss from the subject Mechanical Engineering Materials 1625304. This lecture is according to the SPT syllabus. So we are going to discuss the unit number 1, that is engineering materials and their properties. So this is lecture number 3, and the topic that we're going to discuss today is types of engineering materials part 3. So previously there are 2 parts. If you're not have seen the video, you can just go and see the first 2 videos. Now let's get into the content that we're going to discuss today is about types of engineering materials. So this is a continuation. So in the continuation, what we're going to discuss is crystal structure in metals. So the majority of the metal falls in either of the following crystal structures. So it could be BCC, that is body centered cubic, FCC, face centered cubic, and HCP, hexagonal closed packed. So these are the 3 types of things. So first we are going to discuss about the body centered cubic. So this is the structure wherein which you could see there are 8 corner atoms. You could see the 8 corner atoms. Let me show you with the laser so that you can understand a bit more easily. So this is the 8 atoms, 1, 2, 3, 4, 5, 6 and 7, 8. So which is being connected with a center atom, one center atom. So these 8 atoms, it is shared, that is, it could be called as 1/8 of the atom. So basically body centered cubic is a type of a crystal structure in metal. So this structure can be seen as a gathering of cubes with atoms at the edges and an atom in the center of every cube. So that means you could see every cube has a center atom. That is what the body centered cubic is all about. So every atom, every cube will have a center atom with the 1/8 of the atom. That is, these atoms will be called as 1/8. So this will be shared with another cube also. So this will be shared with another cube also. So this will be shared with another cube. So basically these atoms will be a sharing atom, and this will be a center atom for every particular cube. So the corner or the edge atoms are shared among 8 unit cells. So basically you could see the 8 atoms, right? So these 8 atoms will be shared with other 8 cubic cells. That means that is the reason we tell it as 1/8 of the atom. So 1/8 of the atom, we say it because these atoms are shared with the 8 cubic cells. So the metal which have a BCC structure is a alpha ion. First one is the alpha ion. So next one is the tungsten, chromium and beta titanium. So these are the examples wherein which these materials or these materials which will have the body centered cubic structure. So this is a crystal structure, actual crystal structure. So this was the previous structure which I was shown in the which I showed it on the figure, and this is how exactly it looks. See, you could see the atoms on the cube of the corner, which is not a full atom, so which is only partially is having. So that means only a part is there. So the remaining part will be on the other cube. Only the center atom. So this black area is the center atom, and these red areas are the atoms on the cubes or the side of the cubes. So these atoms, see, this 3D structure can clearly show you that. So this triangle, let me show you with a pencil. See, this area will be connected with the this area will be connected with a different atom, and this area will be connected with the different atoms. So likewise these atoms are connected. That is the reason this is the crystal structure of crystal structures in the atom. So the elements which crystallize in BCC structure shows the property of metallic conductor. So they have a 8-fold coordination in the nearest neighbor shell. So that is a 8-fold. That is which has been, these atoms will be shared by the other cubic cells, right? So this is a 8-fold coordination atoms. So which does not permit saturated bond. So it will not permit a saturated bonds. Okay. So the BCC structure has neither a stacking sequence nor a stacking faults. So therefore it does not have closed packed planes. So that basically doesn't have a closed packed planes. So it is coordination number is 8. So the coordination number would be 8. Let me show you here. So in this structure there are 8 corner atoms and 1 atom at the interior. So in the center of the let me show you with the highlighter. So in the center of the unit cell with no atom on the face. So therefore NAV is the average number of atoms per unit cell. So NC is the total number of corner atoms per unit cell, and NF is the total number of face atoms in the unit cell, and Ni is the center or interior atom. So where in which as I told, right, the BCC unit is comprised of a net of 2 atoms. So it is coordination number is 8. So the coordination number is the coordination number. And the packing factor of a BCC unit is 0.68. So the packing factor is the volume of atom in a cell per the total volume of a cell. So this is the actual calculation. That is NAV, that is a average number of atoms per unit cell, which is equal to NC is the total number of corner atoms in the unit cell, and NF is the total number of face atoms in the unit cell. So NF is the total number of face atoms, so that is a 0, and center or interior atom, that is 1 only. So NC by 8 plus NF by 2 plus Ni by 1. So 8 by 8 is equal to 1, and 0 by 2 is equal to 0, and plus 1 is 1. So totally the average number of atoms per unit cell is 2. So I told you, right, so this will be the atom structure, right? So this is the atom structure. So here one atom will be there, 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 center one atom will be there. Let me show you. So here one atom will be there, here one atom will be there, here one atom will be there. So here one atom will be there, and here one atom will be there. So this is the center atom. So this is the center atom. So 1, 2, 3, 4, 5, 6, 7, 8. So these 8 atoms, that is the total number of corner atom, makes as a single atom. So the total number of atoms makes the total number of 8 atoms makes a single atom. So the total 8 atoms becomes 1, and this corner atom becomes 1. So 1 plus 1 is equal to 2. So that is what we get here, 2. So basically the body centered cubic system atoms has only 2 atoms. So that is average number of atoms per unit cell is 2. That means in a unit cell only 2 atoms will be present. So some of the materials that will be simple metals like sodium, potassium, rubidium, calcium have simple metallic bonding. The transition metals like titanium, molybdenum, tungsten and iron have some contribution to the bonding from the d electron. The d electrons occupy unfilled orbitals in the ion core. The symmetrical or the debonding facility is the PCC structure. So with that, the BCC has been over. Next we'll go for the FCC, that is face centered cubic. So this is the structure of a face centered cubic. So the next one is the face centered. So wherein which a face centered cubic, arrangement of atoms in crystals in which the atomic center are disposed in space in such a way that one atom is located at each of the corners of the cube and one at center of each face. So this structure also contains the same particles in the center of the 6 faces of the unit cell. For a total of 14 identical lattice points, the face centered cubic unit cell is simplest repeating unit in a cubic closed pack structure. So in this diagram you could see, let me show you with an highlighter. So these are the corner atoms. So these are the corner atoms. These are the corner atoms you could see. And these are the atoms which will be present on each side of the cube. So if you take this side, one atom will be present. That is, one atom will be present. So this side, one atom will be present. So this side make it as 2, and this side one atom will be present, and this side one atom will be present, and this side one atom will be present. The bottom side one atom will be present. So totally on all the corners we have 8 atoms, and here there is no center atom. So instead of center atom, there is a single atom. There is an atom which is placed on every side. So basically it has 6 sides, so 6 atoms are there. So how the calculation goes on here is, I will show you example. This is these are the materials. So basically how it is, this is a crystal structure. So when you take this, all the atoms are shared. So that means in body centered cubic also different unit cell has been shared, right? Same wise here also different unit cells will be shared. So when another unit cell is shared, so this atom, that means this atom will be shared with another cube. This will be shared with another cube. This will be shared with another cube. So that means only half a atom will be there. Here it is shared with 1, 2, that means 1, 2, 3 and 4. So 4 atoms here, 4 unit cells will be shared. Here only half, here only 1, so that means half will be there. So in a calculation how it, so in this structure there are 8 corner atoms and 6 atoms at the center of the face of and interior atom. So that means, therefore the average number of atoms per unit cell is 8. So this is 8, and number of total corner atoms in unit cell NC is 8, okay, and NF, total number of face atoms in a unit cell, it is 6, and the number of interior center atom is 0. So NC is 8, NF is 6 and NI is 0. That means that particular atoms, that atom which is placed on every center, every face of the atom, right, it has been shared with a different unit cell. So that means only half unit cell will be considered. So when you take half unit cell, there are totally 6 atoms which has been shared with other face of the atom. So when you take 6 divided by 2, what you get is 3, right? So only 3. And when you consider 8 atoms at the corner, right? So when you take 8 means it becomes 1, right? Because it has been shared with 8 unit cells. So when you consider, it takes 1. So basically 1 plus 3, which is equal to 4. And because there is no center atom, it is directly taken as 4. That means this is a calculation. So average number of atoms per unit cell. So basically in a unit cell, how many atoms are there? Only 4 atoms are there. That is the formula here they have put in. Nc by 8 plus Nf by 2 plus Ni by 1. So basically 8 by 8 plus 6 by 2, which is 3, and answer is 4. So totally 4 atoms are there in a particular unit cell. Okay. So the next structure that we're going to discuss is hexagonal closed pack. Okay. So basically hexagonal closed packed structure will be looking like this, where in which these are the corner atoms. So, and there will be a center atom. This is the center atom. Now center means on the face side of the hexagonal there is a center atom. So this is the top view where you can understand, because there is a triangle over here. There is a triangle over here. This triangle is nothing but this triangle actually. So this triangle is basically this triangle. So where in which there are hexagon has, you know, how many sides? 1, 2, 3, 4, 5, 6 sides, right? So 6 sides, there will be 6 corner atoms, and one center atom will be there on the face atom, that is on the face unit cell. And so 6 in 6, only 3 face, okay, only in the 3 sides, I mean 3 face will be only 3 face sides will be having atom. So this will be having this atom, this will be connected to this, and this will be connected to this. So basically 1, 2, 3, 4, 5, 6, and another 6 will be there, that is 12, and this is 13, and this will be 14, 15, 16, and 17. So basically this hexagonal closed packed atom has 17 atoms. So example, magnesium, zinc, these are the examples. So for hexagonal structure, the corner atoms are shared by 6 cells. So basically the corner atoms are shared by 6 cells. So 3 from below and 3 from above. So face centered are shared by adjacent 2 cells, and 2 and atoms in the interior are shared by only 1 cell. So where in which basically hexagon structure, the corner atom are shared by 6 cells. So basically 6 cells will be shared, okay, and 3 from below and 3 from above. So in the average number of cells would be like formula is Nc by 6 plus Nf by 2 and Ni by 1. So for HP structure there are 12 corner atoms, as I said, 2 atoms at the center of the above 2 faces, that is 2 atoms on the top and one on the top and one on the below, and 3 atoms in the interior of the unit cell, as I was telling. The formula comes like this: Nc is equal to 2 and Nf is equal to 2 and Ni is equal to 2. Basically the value is a 12 atom. So basically it has only 6 atoms sharing, right? So 2 units will sharing, so it becomes like 6. So Nf is 2 by 2, and center atom will be 3. So basically you will get 12 by 6 is equal to 2, and 2 divided by 2 is equal to 1, and 3 divided by 1 is equal to 3. So basically 2 plus 1 plus 3, which is equal to 6. So the hexagonal closed pack has 6 atoms. Understood? So with this we have come to the conclusion. So we discussed about the various types of engineering materials, and we also studied about the crystal structure on the metal. So I hope you guys we understand the different types of crystal structures that are available in the metals. So we discussed about the body centered, cubic, face centered, and hexagonal closed packed. Okay, so These are the reference book. So if you want, you can see this of reference book. Thank you guys. Thank you for listening to this video. We will cover the next topic in the next video. Thank you. Take care. Bye.